Good morning, everyone, or good afternoon, wherever you are in the world. So thanks for joining today. My name is Theodore Tsiozidis. I'm the Managing Director of IDEA StatiCa UK. And this is another webinar in collaboration with the Institution of Structural Engineers. Today, the topic is about fire design solutions in the context of the new Building Safety Act. So I will be moderating this webinar today, and most of the work has been done by my colleague Kostis Hatzopoulos, who is going to present most of the webinar. He is our technical manager at IDEA StatiCa UK. But we also have the pleasure of having with us Ashley Katcha, which is from the Institution of Structural Engineers, who is going to introduce to us the new Building Safety Act. Now, before we begin, just some basic info about the GoToWebinar for those of you who haven't used it before. On the right side of your screen, you have a control panel, so you can by default, of course, you're muted, but you can use this panel to ask any questions that you might have during the webinar. We will be monitoring those questions, and I will try to answer as much as I can during the webinar, but we will also have some time towards the end, hopefully, for some Q&A. So whatever is not answered during the webinar, we will have a look towards the end. So just some basic introduction about today's webinar. So as I said, this is about fire design solution in the context of the new Building Safety Act, which is a new legislation that is already in place. And for those who are not familiar with it at all, it has to do with the design, construction, and in general maintenance of buildings, of high-risk buildings, which are presumed to be buildings who are over 7 stories. So you can imagine that we're talking about thousands of buildings just in the UK. And it has to do with, I mean, it's a big piece of legislation that has to do with a lot of things, but a central, let's say, part of this act is fire design, and this is what we're going to talk about. This is actually the reason why the whole building the new Safety Act began after the tragic events of the Grenfell Tower, and we're going to focus on this topic today. Before we actually start presenting, we just wanted to make a few quick polls just to understand our audience and see how familiar, for example, you are with fire design. So I'm going to start with the first poll, which is, have you ever performed fire design? And if yes, how often? So I'm going to quickly launch the poll. So please, I'm going to leave it for a few seconds, so you can choose whether you are designing for fire frequently, or you are designing but occasionally, rarely, or you haven't performed fire design at all. So I'm going to leave it for a few minutes. I can see that most of you have voted already. Thanks a lot. Okay, we've almost reached 80% of the participants, so that's quite a good number. So just a few more seconds. Okay, perfect. So I'm going to quickly share the results with you. And as we can see, most of you, actually almost half of you, haven't never designed for fire. Some of you, a third of you, have designed but rarely, and the rest is either frequently or occasionally. So this is actually good because it means that we can probably provide some useful information. So let me go to the next topic, which is with regard to the new Building Safety Act. How much information do you have on fire design, specifically on fire design? So I'm going to quickly share this poll. And please choose between either you have extensive knowledge and understanding, or basic knowledge and understanding, limited knowledge but interested to learn more, or no prior knowledge at all. Okay, thanks a lot. We're almost there. I see 80% of the people have voted already. It's very good, thanks. So I'm going to leave it just a few more seconds. Okay, perfect. So let's see the results. And we can see that almost, actually half of you have limited knowledge but interested to learn more. That's actually a very good thing, and we hope that we can provide some information today. And a big percentage, I see 30% have no prior knowledge, which is also a good thing because we can hopefully provide you some information on that. I would also like my colleagues to comment on this. Ashley, how do you see these results? Is this expected?
I think so, Theo. Thanks for these polls, actually. Some quite interesting information here. One of the things it seems with the Building Safety Act is that it's quite nebulous at the moment. So it's at the moment everybody's still trying to very much find their feet with it. So it's good to see that people are very interested to learn more about things like fire design, and especially in a few minutes when I'm going to go through some information as to the context of the Building Safety Act and where the where fire design may fit in if you're asked to do such a thing later.
Okay.
Yeah, no, it's good. Very encouraging.
All right, thanks. Let's finish with the last one, which is, do you see the upcoming Building Safety Act as a potential business opportunity for you? So yes, definitely, I see great potential. Possibly, I need more information to evaluate, or I'm not sure yet, but I'm open to explore it. Or no, I don't believe it offers any business opportunity. Okay, thanks for your votes. A few seconds more. Okay. Very good. Okay, I'm going to close the vote. We have 80% of the participants that have already voted. And let me share the results. And we can see that half of you are actually not sure yet, but open to explore it, which is a very good thing. And basically, most of you see that as a potential business opportunity, with a very small percentage of 12% that think that this doesn't provide any business opportunity. Very well. So I think with this, I will pass the presenter to Ashley to give us a short introduction in the new Building Safety Act and what does this mean in terms of fire design. And Ashley, the stage is yours.
Wonderful. I shall just make sure that we are set up. Can we all see that?
Okay. We don't see you. Yes, now we see your screen. Actually, we see the presenter mode.
Excuse me, guys. Maybe we could deactivate our webcams to make some space for.
Yeah. Yes, let's do that as well. Yeah, that's the slide. Perfect.
Good.
Brilliant. Right. Okay. And I'm going to stop sharing my webcam as well. First of all, I'll say thank you, Theo, for the warm welcome and the introduction. From our perspective at the institution, we are still attempting to flesh out and provide guidance on the Building Safety Act, and in terms of how to really push the best information to our members. So, and as Theo mentioned earlier, the entire premise of this webinar appeared due to the new regulations that have now come into force. So I'm just going to go through some of the aspects which may be relevant to those of you listening. I'm just going to go through some of the resources that are available via various organizations, including the institution especially, and some just some sort of a few different takeaways on competencies and various other things. So as Theo mentioned, the Building Safety Act was brought into place following Grenfell and following the inquiry that took place, the Hackett inquiry. The actual act itself was announced in 2019, following the Tower fire in 2017, and received royal assent, and it became law in 2022. There are several main aims, which are these aren't all of them, mind. So there's 4 listed there, but I just want to sort of draw attention to a few different things with regards to this. This is an extract from our institution's website, so you can view the full thing on there. The legislation is designed to provide greater safety, quality and transparency of the building process and accountability of the professionals involved. So with regards to safety, there are multiple aspects to that. Of course, there's sort of a structural safety aspect of things, but as Theo mentioned, the entire act was born out of the Grenfell Tower fire and deficiencies identified within the actual construction industry. And so the safety, quality and transparency is all coupled with the accountability of professionals involved. Now, one of the main aims is to provide clearer accountability and stronger duties for those responsible for the safety of high-rise buildings. Now, HRBs are now classified as high-risk buildings. So those, as Theo mentioned, over 7 stories or 18 meters from, I believe, the lowest point to the floor level of the top inhabitable floor. So, you know, if you've got a roof space which is associated with just plant equipment, that isn't included in that 18 meters height. So it'll be interesting to see how the building landscape changes as people begin to sort of understand these things. Clear competence requirements and maintain high standards, and we'll go into what that means just very quickly. A lot of the institution's guidance will reference this document, which is the PAS 8671, specifically in this case for sort of competence levels and for principal designers. We, as structural engineers, we are designers, and there are a few different aspects with regards to this the BSI PAS 8671, and also its reference documents, the BSI Flex 8670. If we have a look at the table just here, the third column in, for example, fire safety, structural safety, and public safety are all categorized into sort of one sort of competence area, and within that, marked on in that column are the legislative and regulatory requirement for compliance, management of design work compliance, and technical framework for compliance. And really, that's pretty much the crux of this webinar, to improve technical understanding and to sort of begin to really lay out the aspects of how structural engineers can begin sort of responding to the new requirements. You'll see at the top there sort of the levels of understanding and adoption, and specifically in this case today, it's about analysis, evaluating, and creating. With regards to the background of fire design, whether you need to complete it as a structural engineer, of course, will come from design requirements. It will come from the stage at which your building design is at, and the application of that information, depending on the site constraints, depending on the building layouts, depending on your work with other consultants as well. There are cases where you may need specialist fire modeler, for example, and those that's not really covered here as such. So in those sorts of very specific cases where there may be higher order requirements, it's a good idea to sort of seek advice where required. From a structural perspective, this webinar is also providing some information on the software, its capabilities, and in order to understand how the sort of level of capabilities and what's available to structural engineers, in order to sort of not only understand what they can do, but understand what their limits are really. So I'll just get into that pretty quickly. With regards to fire design, there are two potential areas where you may be required to provide verification that the structure is is compliant with the legislation, primarily building regulations, and that's really Gateway 2 and Gateway 3. Now, planning Gateway 1, where you may be involved, actually, it depends on, of course, the project basis, but generally speaking, if it's a larger building, you may be involved. If it's something slightly smaller, then you may not be. But of course, in the case of HRBs, we're looking at sort of quite tall buildings, so generally structural engineers will be consulted. And really, the requirements as to what needs to be provided at the planning stage is adopted into Gateway 1, effectively. Gateway 2 is before the building work starts. Effectively, this is very similar to the building reg submission. However, the new regulatory scheme will have the power to not allow any building work until sort of that gateway is passed. Between Gateway 2 and Gateway 3, there's an area where there's a sort of change management aspect to it, and Gateway 3 is when the building work's complete, and that's some of the golden thread work that we're currently undertaking. At Gateway 2, applications must demonstrate how proposals comply with building regs. Building regs should be considered holistically with an outcome-focused approach, which includes appropriate consideration of building safety. Duty holders should not consider compliance with building regulations a tick box exercise, and this is really it. So in order to really understand, for example, things like how to mitigate problems with concrete or steel or something similar, with heat and fire, it's really important that we really understand sort of what the software is capable of, how we do the design, the background to the fire design. I'm not sure whether the process is going to cover background to fire design, but I'd suggest, obviously, there's lots of things to do on fire design. It can be quite complicated. I'm sure you're all quite aware. Gateway 3 application was demonstrate how the building work complies with building regulations and to provide assurance that building is safe to occupy. And also on this is the as-built information. So that will include data from analyses, outputs from FEA models and such. The institution will be probably providing guidance on that soon with regards to sort of what sort of things you might want to include in order not to overwhelm the overall golden thread. But that may be a case where you might provide some of the fire design information. Now, the institution does have lots of, so these screenshots that I've been showing are all available on the institution's website via Resources and Building Safety Act. So please do have a look, and there's lots of information there on the impacts on the role of structural engineer, gateways, safety cases, golden threads, the processes for new buildings, and in the case of existing buildings, they're also sort of maybe sort of how they'll be assessed under the Act. So from a digital perspective, my primary role at the institution is to deal with the aspects of digital workflows, computational design, and we cover, everything from sort of more established things to sort of more emergent things, such as analysis and CFD and pushing forward to off-site manufacturing, closed loop, some Grasshopper on there if anybody's interested, and to the sort of more esoteric things, what's on the horizon, AI and all that sort of other stuff. But throughout this process, there's something that's really quite important, which is a focus on competence of the engineer. And I found this next slide quite interesting, actually. This is one of my favorite quotes, actually. It's from Jurassic Park. If you can do something, it doesn't mean you should, basically. That's Jeff Goldblum from Your Scientists were so preoccupied with whether or not they could that they didn't stop to think if they should. And it sort of gets to the crux of things. Yes, you can do things. You can plug information into an FEA software, and but that doesn't mean you should be plugging that information to FEA software. And this webinar is part of trying to provide engineers with a tool set that they understand, and something that's cropping up again and again within digital engineering. Understanding of the tools we use is essential in order for understanding capability and to recognize the limits of knowledge. And so we want to sort of keep in the top portion of this triangle here, where we are unconsciously competent and consciously competent. So we always have the right intuition and right analysis, especially when it comes to building safety. What we don't want is conscious incompetence, where we plug away into FEA such, and garbage in, garbage out, and we don't really understand what the information coming out of the software is, and we don't really have a good handle on what the information going into the software is. And we want to stay absolutely away from this sort of unconscious incompetence where we perhaps have no idea what our capabilities are, and agree to something perhaps that's a little bit over our heads without even realizing. So hopefully this webinar will be useful to many of you as a way of improving your knowledge of the existing landscapes of capabilities of modern design software, and improving your understanding of the software solutions available, and recognizing where perhaps you should be seeking additional advice with regards to sort of fire design, and when you can perhaps undertake some analysis yourself, especially in areas where the design criteria are or constraints are sort of non-standard. That was a brief run through. Please do look at our additional resources on the website. There's plenty out there. There's also video content as well as to sort of how these things impact. We have information from also on the insurance front as well. So please do have a look. And with that, I shall pass on to Kostis.
Thank you, Ashley.
I'll just stop sharing my screen now.
You just need to make me the presenter. So
I think that's going to be Theo.
Yes, I will do that.
Yeah, lovely.
Thank you, Theo. Okay. Hope you can see my screen now.
Yep,
yes.
All good.
Good to go.
Okay. So welcome everyone, also from my side in this webinar. And before we move to the actual demonstration and looking at the available information on the new BSA, what's important from the engineer's perspective is some key concepts I have identified that relate to the way we practice engineering. So we see a lot that the term competence is often mentioned. I also saw the phrase new safety cultures, which according to my interpretation refer to the engineering judgment required by the responsible engineer who needs to identify and reduce risks associated with a specific structure, not just the risks that are implicit in the application rules described in the code. So in this respect, it's now essential to have tools that can deal with uncertainty. We need to be able to perform advanced type of analysis for many scenarios that are associated with the hazards that are identified by the engineering team. We also call this practice sensitivity analysis. So what we do in IDEA StatiCa is that we have developed a line of tools that does exactly that. We offer advanced type of analysis in a straightforward and transparent way where the designer can easily evaluate the performance of the structure under the code requirements in many iterations. So what used to be weeks or days of work is now hours. Now, specifically to fire design, most often designers use simple or the tabulated methods, or they also apply fire protection. However, there are cases where fire protection is not applicable. For example, when we renovate a building and we need to remove fire protection due to temporary works. Or there is also the case where the designer is interested to save resources and protect the environment, because we all know that fire protection is environmentally demanding. In this webinar, I will demonstrate the tools that IDEA StatiCa developed to help engineers deal with the situation where the fire protection is not available at all. Before we move to the demonstration, I will give a brief introduction to the principles of fire design. Of course, fire design is a huge topic on its own, and it's something that should be covered by an institution like IStructE or the universities. But I'm just going to provide some context to the demonstration and show you where you can start to find information. Like, for example, right now we have, we have information in Eurocode 1991-1, 2, and this part is called Actions on Structures Exposed to Fire. In this part of the code, two approaches are identified. The first approach is what we call prescriptive approach, which uses nominal fires to generate thermal actions. However, there is also another part, the performance-based approach, which is using fire safety engineering, which seems to be favored in the context of the BSA and refers to thermal actions based on the physical and chemical parameters. In IDEA StatiCa, we follow the second approach as we analyze parts of the structure. And in order to streamline the analysis of these parts, we have developed a tool called CheckBot. I will demonstrate it, which transfers members together with their boundary conditions under equilibrium in the respective package. This is very important. In this part of the code, it's also defined. It is also defined the load-bearing requirement of the structure during fire exposure. And basically, this is an accidental design situation. In this situation, the representative action of the variable load is defined, and the purpose of the design should be that the structure should be able to resist the calculated loads during this under this accidental situation for the required fire resistance, which is usually denoted by the letter R, which followed by the time in minutes. Another important aspect of the calculation is the selection of the temperature time curve, which is basically the gas temperature of member surfaces as a function of time. In IDEA StatiCa, we used the conventional curves as defined in the code. In addition to this generic part, which outlines the design procedures, there are specific rules that apply for each material. In IDEA StatiCa, we have solutions for steel connections. We also have solutions for concrete members. So parts of Eurocode 1992-12 and 1993-12 are applicable in this case. Please note that in the near future, we're also extending this IDEA StatiCa member solution to also cover steel members. This is what we call a steel degradation curve, which is defined in the code and basically defines the yield stress, which is now a function of temperature, and the yield stress drops significantly under elevated temperatures, or to put it simply, there are reduction factors for the properties of the material, and as the temperature increases, these factors cause a significant drop in the corresponding properties. In IDEA StatiCa, we call these graphs here degradation curves. For our worked example, I will use a simple fictional structure I have created in a global analysis software. This is basically a steel platform that is supported on two concrete frames. The fire protection is stripped due to temporary works, and at this point, I need to stress out also that I will use CheckBot to transfer parts of this structure into IDEA StatiCa tools. And CheckBot does not only work with the specific software that I will use for the demonstration, but it works with the most important structural engineering tools out there. We have more information for what we call beam links in our website. So let's move into the global analysis software where the structure is calculated. And we can see that we have a platform loaded with its self-weight, covers variables loads. Let me open the combinations dialog, where we see that we have several combinations for both ultimate and serviceability limit states. And we also have the accidental combination for fire design, starting with fire prefix. Now let's deactivate the loads and move to the still design module or the software, where I will open the still design settings, move to the fire resistance options, and there I will define the required fire resistance for 30 minutes. Then I will go with the default Eurocode temperature time curve, which is the ISO 834 one. And lastly, I will set the analysis type to be resistance. I will close this dialog and then move in our global analysis software to perform the still fire check. So everything passes in the software, everything is green. So I can now proceed with the fire design at the connection level. After that, we will also do fire design for the concrete frames. So I will export the structure to IDEA StatiCa checkboard. This will not take long because I have already done this. And obviously the whole structure has been transferred, and we can see steel members in blue and the concrete frames in gray. Now let's switch the view to transparent so that we can see the cubes that denote, that indicate the locations of the connections. I have also exported the members of the concrete frame that will be designed in the next section. And at this point, you may be wondering why we need the intermediate representation of the structure. So for both the connection and the concrete frame check, we need to export substructures and create sophisticated submodels like the one displayed under the properties to ensure that we can reproduce the expected behavior from the global analysis. We need to have the boundary conditions of these submodels matching the ones of the global analysis software. So everything is transferred in checkboard, including the loads and the internal forces. So for example, in a bit, we will also be able to display the moment and shear force diagram that we have imported from our global analysis software. Now, moving into the loads dialog, I can see that all combinations have passed through for both fire design and ultimate limit states. So let's close this dialog. And next, I will select a corner node, and I will proceed with its design in IDEA StatiCa connection, which is specifically made for the which is specifically used for the design of connections. Let's wait a bit. And now that the import is over, we can see that the node, the geometry of the node and the incoming members have been imported together with their combinations. And the import procedure ensures that there are no unbalanced forces at all. We can see that at the table below, which means that this substructure is in total equilibrium. So yeah, we can see that in this table in the properties panel. Now, before we continue with the fire design, we need to create the connection with several operations and make sure that the node works fine under the ultimate limit load state. So for this, I need to deactivate the fire design combination. And to save some time, I will use our new template system, which is called the connection library, and apply a template I have created. Let's select template, press OK, and I will apply it using M38.8 bolts Now, the template was applied. It needs some fine tuning, but I will skip this to save some time. And I will now perform the ultimate limit state check, which is basically a prerequisite for the fire design. If the connection does not pass the ULS checks by a large margin, it will not be able to pass the fire design check. This is a rule of thumb, baby, a rule of thumb. So we need to calculate the connection and check the results. Let's wait a bit for the calculation to be over. It will not take long. So after solving, a short summary appears at the top left of the graphics window, where we see very low utilizations, and activating what we call the overall checks provides a colored view of the connection, where we can see the gray color that indicates that this configuration remains in the elastic region under the ultimate limit state. So we'll make an identical copy of this connection. Move to this new model, and I will proceed with the other type of analysis, which is fire design analysis. And in this analysis, I will reverse the process of loading. I will deactivate all ULS loads and will leave only the load case corresponding to the fire design, which is fire-1. Again, this is in equilibrium. And at this point, we need to define the material temperatures for fire design condition calculated in our global analysis software. So we need to move back into the global analysis software and find out from the calculation the material temperatures. Let's identify the corresponding connection members of corner connections. So there they are, and we need to open the calculation report to find out the temperature. Right now, we're looking at the temperature of, we will look at the temperature of the column. Which is, this value can be taken from in this specific software, it can be taken from the material temperature in the fire resistant results, which is basically 719.32 degrees Celsius. I will also take the relevant values for beams. So I'm not going to show this procedure here to save some time. Move back into the software. And I will set the temperature for the column. I will pick the column in the graphical window. And then I will set the temperature for the rest of the members according to the calculation of the global analysis software. Please note that I will set this value also to the connected members like bolts, welds, plates, stuff. So I'm selecting all of them. Let's accept this definition, and I'm ready to just press the calculate button and see what's going on. Now the software performs a materially nonlinear analysis. However, this time the analysis takes into account the material degradation, and as the fire temperature rises, the yield stress of its material is modified accordingly at every step of the solution. So the solution is over, and we can now see, again, we have a short summary at the top left, and we can see that everything passes, everything is green, besides two bolts that are red. So we have a marginal failure of this bolt. And of course, it's noteworthy that changing the bolts to pass the fire design checks is very cheap compared to the use of fire protection or something else. We should also consider that in this scenario, the application of fire coating is impossible because we're working at a stage where fire protection is removed. We can also have a look to the results in much more depth. So let's move to the blades, where we can see that for each blade that is available in that for each blade we display the material temperature, a very low yield stress according to this temperature, and of course stresses and strains, which are the ultimate criterion in IDEA StatiCa, as we go with the Eurocode 1993-15 rules. So something is going wrong. Let me move my pre-recording. So there it is. We have the very low yield strengths, the temperatures, and then we can move to the welds again to see that we have the same effects here. We have temperature, we have lower utilizations, and of course, by expanding this row, I can display the code formulas, where one can see that there are the reduction factors I was demonstrating from the degradation curves. We also have the same effects on bolts, where again resistances are reduced, and depending on the developed temperature. So I can also expand the results row and display similar results like in the similar reduction factors. With this, I conclude the steel connection design example, and I'm returning back to the slides. So we have to run a little bit and going back to the introduction for concrete design, and in line with what applies to steel, there is another part of the code, Eurocode 1992-12, which defines additional requirements for concrete design. This part of the code defines the drop in material strength as the temperature rises, and the curves shown in this graph depend also on the type of aggregate. We have similar curves defined for the reduction in strength of the reinforcement. And we also have another parameter that affects the calculation for concrete, which is the moisture content of the member, which affects the specific heat according to the curves in this slide. The good news is that the code allows you to conservatively ignore the moisture content by setting it to 0. So let's move back to Checkbot for the final section of this presentation and move to the design of the concrete frame. So again, we will start Checkbot, where I will deactivate the connections to get them out of the way. And I'm selecting the concrete frame I'm going to design, which is now highlighted, and I just need to press the open button to take it into another application, which is called IDEA StatiCa member, where we will do the thermal analysis for this concrete frame. Here, the concrete frame came through, maintaining its original geometry, cross sections, materials, but also the lateral supporting members called related members. And while some may consider this unimportant, these related members are part of the substructure, transferring loads and also providing lateral support. And since we're interested for an advanced analysis, it is important to account for their influence without providing results or checking them. And for this concrete frame, I just need to activate fire design. And now I have a new item in my tree called fire exposure. As a first step for the thermal analysis, I need to define which of the imported combination is the one for the fire design. So I need to select the relevant combination, fire 1. And while we wait, we can see that loads appear from the analysis, and we can see that there are load concentrations at the location of the central beam and the reaction, which is something that makes sense, since this is a sub-model under equilibrium. So for this specific combination, I just need to move to its check type and set this to fire resistance. The next step is to open the settings dialog. And here I have to go to the fire design settings, where I will set the fire resistance class to R30 to match the settings of the global analysis model of the original analysis. Then I need to set the fire curve type, and I will set it to the standard fire curve, which is the ISO 834 one, which is the one I also used in the original model. Please note that we'll have the option to use other curves also. And now we can also move and display the material degradation curves that are available for concrete and reinforcement. So for concrete, we have many curves. We also have the curves from the code for reinforcement, where we can see that the yield stress drops depending on the applied temperature. So let's close this dialog and move a little bit further. And now I will define the fire exposure data, which means that I need to specify how the members are exposed to fire. To do so, I will create a fire exposure group for the columns. I will graphically select them. So the software identifies the cross section, and I will leave it as it is. So my columns will be exposed to fire on every face. Anyway, I also have the option to set the initial material temperature, which is 20 degrees in this case, the default in the code. And of course, I also have the option to set the moisture content for concrete. Of course, on the safe side, we can set this value to 0% according to the code and be a little bit more conservative. I will also add another fire exposure group, this time for the beam. Now, I'm assuming that the beam supports slab at the top. So in this case, the top part of the beam is not exposed to fire. And this will influence the thermal analysis, as we will see later. And now that everything is okay, we can move and add reinforcement into IDEA StatiCa. First, I will add reinforcement to the leftmost column. I will just graphically select the reinforcement editor, and I will go with a wizard that is available in IDEA StatiCa. Let's put some random values here and accept the definition. And now I can preview the applied stirrups and reinforcements that will be used for the analysis. I need to repeat this procedure for the column at the beam, but I will skip them, the details, to save some time, and I can zoom in to also display how this thing is modeled, where we have realistically applied the reinforcements. So everything is ready to be calculated now. I just need to press the calculate button and have an initial linear calculation. Everything passes the checks, but there are some question marks for the SLS checks, which have been neglected as I did not transfer the corresponding combinations. Apart from that, I can look at the detailed calculation results for this stage. So I can see the capacity curve of the selected member, which is the beam in this case, at the different sections. The capacity curve is located under the table. And now, after that, we will move to the advanced thermal analysis calculation. And to do so, I pressed the GMNA button and calculate. First, a thermal analysis starts, which will be used as an initial state for a materially nonlinear analysis. At this stage, the structure is divided by the software in several sections, and each of these sections is meshed using finite elements, and heat transfer is calculated at the section level at the time indicated by the fire resistance class, which in this case was R30. Now the label changed to materially nonlinear analysis, so we will perform several such analyses for all ultimate limit state checks, starting from the results of the thermal heat transfer analysis. Now, after the end of this analysis, the results for both ULS and fire resistance are displayed. And before looking into the detailed results, it makes sense to ensure that this materially nonlinear analysis is valid. And to do so, I must perform a linear buckling analysis and check if the critical factors from this are over 15. If the factors are over 15, I can safely assume that the results are valid. Otherwise, I need to carefully select and amplify appropriate buckling shapes that will serve as imperfections for the GMNA analysis. So I'm pressing the LBA button and moving with another calculation, which in this case will calculate the buckling shapes and the corresponding amplification, and the corresponding critical factors. Now, the linear buckling analysis is finished. The software displays the buckling shape. I can also see at the top left the minimum amplification factor, or alpha critical, which is obviously greater than 15. And this means that my M&A and fire design results are perfectly valid. As a result, this unprotected concrete frame can maintain its load-bearing capacity for 30 minutes under the fire design situation. So let's have a brief overview of the calculation results. The critical utilization and its position in the corresponding member is displayed in this table, and this table can be folded or expanded further to reveal the utilizations at the different positions of the member. I can also look to the results of the thermal analysis. So I click the temperature, and a small table appears showing the locations of the maximum temperatures for the concrete and reinforcement in accordance with the previous results. I can also click on the detailed button, which will display the sections created for the thermal analysis on the frame. And so let's select from the table member B2, expand the row to display the critical positions, and select the critical one, which is 0.06. And I can see the calculated temperature gradient displayed below the table. We can see that the temperature increases as we move to the outside of the column, while the internal one is set to 20 Celsius degrees, as I defined it in the initial settings for this member. And I can also graphically click on any section in the graphics window on the frame. I will click on the section near the center of the beam. Okay. Now the graphical representation of the temperature gradients changes, because this time the top edge of the beam is protected, so we can see how this affects the overall distribution. We have similar results also for stresses and strains, which are the ultimate types of checks for this type of the calculation. And by pressing the stress button and keeping the code check to detailed, I can see stress results for both concrete and reinforcement at a particular position on any member. For the reinforced concrete section, stresses and strains are calculated as a function of the material degradation curve, and heat transfer results at the specific section. So let's move to member B2, select the position. We can see graphically the stresses in the reinforcement. And if I click on the concrete tab, I can also see a similar graph for my concrete stress distribution. We have similar results also available for strains, but I will not go through them to save some time. And what is important is that stress and strain utilizations are displayed. And in this case, everything is less than 30 or approximately 30%. I'm sorry, it's not 30, it's less than 90%. So this means that the concrete frame passed all checks. And with this, I also conclude my concrete example, and I will close the webinar here. So the key takeaways for our toolset is that we can easily transfer accurate structure sub-models under equilibrium. And this is how we can deal with uncertainty, especially in complex structures. The FAR design workflow is streamlined, even for structures demanding advanced type of analysis like GM and IA. This means that the engineer has the option to perform several design iterations, which is basically a requirement in the BSA. You need to do it many times fast. And lastly, we have intuitive and interpretable graphical results for any step of the calculation that will help you identify potential outcomes for any identified hazard scenario. So I think that I can move the presenter back to Theo, who can to the Q&A session. I'm not sure how much time we have available.
Yeah, we don't have a lot of time. Actually, we're out of time. We're over 1 hour, but let's keep your screen for now. And I just wanted to, I think I will just mention 2 questions that have been answered. The first one is if the global analysis was at ambient or elevated temperature.
The global analysis, can you please repeat the question?
If it was at ambient or elevated temperature.
No, it was for ambient temperature. The global analysis was not so sophisticated.
Okay, perfect. And there is another question. I think this one is for Ashley, probably. It is quite concerning to see that only 4% of participants have extensive knowledge and understanding on fire design, but far more than this admit to having undertaken fire design. Can you please comment on that?
Yes, actually, it's very, very interesting. And I think that actually, that on that note, actually, Theo, I wouldn't mind having a summary of those polls. I think that would be quite interesting to
yes. Let me quickly share my screen. Yeah,
please do. Yeah,
share my screen. Give me 1 sec.
I think that's better because I think it was blank before. So yeah, no, it's a very good observation actually.
So I have summarized here the answers.
Yeah,
I'm not sure if you can see it. Yeah,
wonderful. That's very quick work, Theo. Thank you.
So yes, as we can see, there is 4% extensive knowledge, but as we can see, for those who have performed fire design, the number is quite bigger. Yeah, it's a really interesting question.
Yeah, no, it's interesting to know, and it comes really back to competences. A big part of competence is I suppose understanding what you know and understanding what you don't know. And I think that perhaps if those who are performing the fire design have only a basic knowledge and understanding, I would hope that many of those people would be seeking additional guidance, either from those who are sort of more knowledgeable. For example, in the past, I've contacted, for example, the Concrete Centre in order to actually sort of gain some better understanding on sort of fire design and cover specification for concrete. And I think it's really quite telling that often structural engineers are asked to do or feel that they need to do certain things that are perhaps a little bit out of their scope. And it's always important for structural engineers to really understand what they're capable of, what their capabilities are in terms of software, in terms of expertise within the practice, and also where they should be saying to either their clients or other consultants, look, we don't have the expertise to deal with this. We will need to get somebody else in. And I think part of the Building Safety Act is about really understanding those competences and where to sort of draw the line. The onus is going to increase on engineers with regards to safety. And so if something were to go wrong, there may be consequences as a result if you cannot demonstrate sort of competence, you know, and the stuff that Costas has just gone through with regards to analyzing structures, analyzing frames, and analyzing connections. It goes a long way to sort of boosting that knowledge. But I would say that it's always a good idea to get some outside help if required, especially with regards to things like fire design, which can be quite complex. And hopefully, you know a little bit more thanks to Costas's run through of sort of some of the technical capabilities of IDEA StatiCa. And software like IDEA StatiCa really does help, because it can help streamline the process, make it much simpler to understand the analysis. And also, I know that IDEA StatiCa's documentation is very good as well. I don't know, Kostas, whether you can point people to the blog or something similar, so that people can really sort of understand some of the technical background behind the CB component-based FEM and heat transfer models.
Yes, thank you for this question, Ashley. Basically, everything is open in our website. So if someone needs to have more information, he can go to IDEAStatiCa.com, where we have a very rich support center, and he can look through our search bar for fire design topics, and we're explaining many things for basically what we do for fire design and how we do it, and where it is required. We also have some additional links. They can also, if anyone wants to have more information, he can also reach me directly through my email. So
okay, we have more questions. We have a lot of questions, but we're obviously completely out of time right now. But just very briefly, Ashley, one last for you. Is there going to be any guidance for fire load from electric car, particularly for basement car parks, with basements moving from 10% EV to 100% EV capacity? Increased fire load, duration, and temperature is a concern. So is there going to be any guidance?
Good question. Very good question. No, but it's something, well, not that I'm aware of at the moment. Of course, sort of from my perspective, I'm sort of the digital side of things. So for me, it's primarily more about software implementation and improving engineers' access to design tools. But it's definitely something. It's definitely something to consider. I will actually pass that information on to some of our, because we do have a car park design guide. So I wonder whether that will soon be covering something similar, but I will pass those details on. So I appreciate the feedback. That's a really good insight, actually.
Okay, perfect. And I think with this we can conclude the webinar. Thanks a lot, Ashley, for your participation.
Thank you. Really good information from the audience and everybody else as well. So
yes, it was really interesting. Thank you, Kostis, as well. Thanks, everyone, for joining. And we hope that we will see you again in one of our next webinars. Thanks a lot, and enjoy the summer. Bye-bye.
Cheers.
Thank you very much, Kostis.